Have you ever wondered if the world's oceans could help save the planet? Picture this: the oceans, vast and mysterious, covering over 70% of Earth's surface. But beneath those shimmering waves lies something far more important than we realize. The ocean plays a critical role in regulating life on Earth. It's not just a beautiful expanse, it's an engine that powers our planet's climate systems. What if we told you that the ocean absorbs nearly a third of the world's carbon emissions? That's right. The ocean acts as a giant sponge, soaking up carbon dioxide at an unimaginable scale. But what happens when that system is disrupted? What happens when the ocean can no longer do its job? The consequences could be far more devastating than you can imagine. Today, we're diving into the mysterious role the ocean plays in the carbon cycle, a process that could hold the key to solving climate change. And understanding this vital relationship could change how we think about our environment forever. We've all heard about global warming and the threat of rising carbon emissions. But do we truly understand where all this carbon goes and how it affects us? It's easy to point fingers at factories or cars, but what if I told you that the real solution could be found under the waves? Imagine a world where the ocean's ability to absorb carbon is severely reduced. What would happen to our climate if the ocean couldn't hold up its end of the bargain? Well, we might not have to imagine much longer. The ocean's delicate balance is shifting, and we need to understand why it matters. So how does the ocean absorb carbon in the first place? Let's journey beneath the surface and uncover the secrets of the ocean's hidden power. The ocean's role in the carbon cycle is like an intricate dance, a dance between the atmosphere, the ocean, and life itself. And it starts with a process we often overlook: photosynthesis. The ocean absorbs carbon from the atmosphere through tiny plants called phytoplankton. These microscopic organisms are like the lungs of the ocean, breathing in carbon dioxide. They use the carbon to grow, then release oxygen into the atmosphere. Sounds simple, right? But this process has global consequences. Without phytoplankton, the Earth's atmosphere would be a far more dangerous place. Yet the ocean's role in the carbon cycle doesn't stop there. As marine creatures die, their remains sink to the ocean floor, locking away carbon for millennia. This long-term storage is an essential part of the carbon cycle. Without it, carbon would be released back into the atmosphere, driving the cycle of climate change. But as we all know, nothing stays constant in nature. Overfishing, pollution, and rising temperatures are starting to disrupt this delicate process. What happens when the ocean's carbon-absorbing capacity is compromised? To answer that, we need to understand the true scale of what's at risk. So what exactly happens when the carbon cycle goes awry? And more importantly, how does this affect us on a personal level? Stay tuned, because the answers are coming, but they aren't what you might expect. In the next part, we'll explore the science behind the ocean's carbon absorption. We'll also uncover the unexpected consequences of disturbing this delicate balance. Hold tight, because the more we understand, the more urgent the situation becomes. As we dive deeper, the ocean's true power and its fragility will be exposed. And it all starts with something we often forget: the invisible link between the ocean and the air we breathe. So, how does carbon flow from the atmosphere to the ocean? The process begins with the simple act of carbon dioxide diffusing into the ocean's surface waters. But it's not just about the carbon entering the water. It's about how it's stored and transported. And to truly understand this, we need to talk about the ocean's carbon pumps. These natural systems pull carbon from the surface and store it deep below. If this pumping process fails, the carbon stays on the surface, accelerating global warming So let's dive into the mechanics of how these pumps work and what's at risk. Ready to explore the ocean's role in the carbon cycle like never before? Keep watching, because the ocean holds more power than we've ever realized. And now, we're about to uncover the hidden dangers lurking beneath the surface. The stakes couldn't be higher. Stay with us as we reveal the science behind the ocean's carbon pumping power. We're just getting started, and the more we discover, the more urgent the situation becomes. The future of the ocean and the planet depends on what we learn today. So let's dive in. Let's take a deeper look. Now that we've set the stage, let's dive into the heart of the matter. The ocean is not just a passive participant in the carbon cycle, it's an active force. In fact, it plays a pivotal role in regulating the Earth's climate. Every year, the ocean absorbs around 25 to 30% of the carbon dioxide we emit. That's a staggering number, equivalent to billions of tons of carbon. The question is, how does the ocean manage this feat? It begins with the surface layer of the ocean. Carbon dioxide from the atmosphere dissolves directly into the water, much like air into soda. But not all of it stays there. Some carbon is absorbed by marine plants, like phytoplankton, which carry out photosynthesis. As these tiny plants grow, they take in carbon, just like land-based plants do. But here's the twist. Unlike land plants, the ocean plants work 24/7, all year round. So, the ocean's ability to absorb carbon is constant, unlike the fluctuating cycles on land. In this way, the ocean acts as the Earth's unsung carbon sink. But it doesn't end with phytoplankton. When these tiny organisms are consumed by marine animals, the carbon enters the food chain. Larger fish and other creatures feed on them, passing the carbon further down the line. But here's where it gets even more interesting. When these marine creatures die, their bodies sink to the ocean floor. This process is known as the biological pump. As these bodies decompose, the carbon they carry gets trapped in the deep ocean. There, it remains out of circulation for hundreds, even thousands of years. This is the ocean's method of long-term carbon storage, helping to keep excess carbon away from the atmosphere. But the system isn't foolproof. Rising temperatures, pollution, and acidification are threatening this delicate process. In fact, the more CO2 the ocean absorbs, the more acidic it becomes. Ocean acidification is already having a significant impact on marine life, particularly coral reefs. Coral reefs are vital to the biological pump, serving as the foundation of marine ecosystems. But when the ocean becomes more acidic, corals begin to weaken and die off. This not only disrupts marine life, but also reduces the ocean's ability to absorb carbon. So what happens when these carbon-absorbing processes begin to fail? The Earth's carbon cycle becomes unbalanced, and the consequences are dire. The excess carbon in the atmosphere contributes to global warming and climate change. But we're not just talking about a small increase in temperatures. If the ocean loses its ability to absorb carbon, the planet could warm at an alarming rate. Scientists predict that the Earth's temperature could rise by several degrees Celsius. That might not sound like much, but this shift could have catastrophic effects. From extreme weather events to rising sea levels, the planet would be unrecognizable. And it doesn't end there. This imbalance would disrupt ecosystems, agriculture, and human societies across the globe. So, what can we do to protect the ocean's ability to absorb carbon? First, we need to stop harming the ocean. Reducing pollution, curbing overfishing, and addressing climate change are all critical steps. But there's also hope in new innovations. Scientists are exploring ways to help the ocean enhance its carbon absorption. Techniques like ocean fertilization aim to increase phytoplankton growth, boosting carbon capture. But these solutions aren't without controversy. Some worry that artificial intervention in the ocean could cause more harm than good. Others argue that we don't have a choice. We must act now. The stakes are incredibly high, and the solutions are still being debated. But one thing is clear. The ocean's role in the carbon cycle is far from understood. We are only beginning to realize the full scope of its importance. And as we dive deeper into these challenges, we must consider the bigger picture. The ocean is not just an isolated part of the planet. It's part of a complex, interconnected system. What happens to the ocean affects everything on Earth. Our future depends on how we treat it and how we protect it. But how do we make sure the ocean continues to play its part? What actions must we take to ensure it remains a carbon sink for generations to come? These questions don't have simple answers. And as we'll see in Part 3, the solution may lie in an unexpected twist. Stay tuned as we reveal the hidden dangers of disrupting the ocean's carbon cycle. The effects are far-reaching, and the consequences are more complex than we realize. Our actions today will shape the world we leave behind. But there's hope if we act now. Let's dive deeper and explore the potentai. Just when we thought we had it all figured out, a twist emerges. What if the ocean's role in the carbon cycle is even more complex than we realized? We've learned how the ocean absorbs carbon dioxide and stores it for the long term. We've explored the challenges that threaten this delicate balance. But here's the kicker. What if the ocean itself could be part of the problem? It sounds counterintuitive, doesn't it? After all, we've been counting on the ocean to help us combat climate change. But new research has shown that under certain conditions, the ocean might release carbon back into the atmosphere. This phenomenon is known as outgassing, and it's something we need to be concerned about. Outgassing happens when the ocean's surface waters warm up, releasing stored carbon back into the air. The more the ocean heats up, the more carbon it could potentially release. So, in a warming world, the ocean could shift from being a carbon sink to a carbon source. Imagine that, a vicious cycle where the very thing we rely on to absorb carbon becomes a contributor to the problem. But there's more. What if the process of ocean acidification, while harmful to marine life, also exacerbates outgassing? As the ocean becomes more acidic, its ability to store carbon diminishes. And in some regions, this acidification accelerates the release of carbon back into the atmosphere. This feedback loop could push us beyond the tipping point. The ocean, instead of helping to fight climate change, might inadvertently fuel it. Scientists are racing to understand the full implications of this. But one thing is clear. This isn't just about protecting marine life anymore. It's about securing the future of our planet. If the ocean can no longer help us absorb carbon, where do we turn next? We may be left with few options, and each one could be costly. But there's still hope. Despite the challenges, the ocean is incredibly resilient. Researchers are investigating ways to enhance the ocean's carbon-absorbing abilities. Methods like marine permaculture and artificial reefs are being explored as potential solutions. But these solutions are still in their infancy, and they come with risks. Could these new methods inadvertently cause more harm than good? The balance is delicate, and every intervention needs to be carefully considered. But there's another possibility that might surprise you. While we've focused largely on the ocean's physical processes, there's a growing field of research into ocean ecosystems. Could marine biodiversity play a crucial role in stabilizing the carbon cycle? Some scientists believe that healthy, biodiverse marine ecosystems could enhance the ocean's carbon storage capacity. Coral reefs, mangroves, and seagrasses have been shown to sequester carbon at higher rates than other ecosystems. Protecting and restoring these ecosystems could be one of our most effective strategies. It's a strategy that focuses not just on the ocean itself, but on the intricate web of life that sustains it. By safeguarding marine biodiversity, we may enhance the ocean's ability to absorb and store carbon. But we need to act fast. Many of these ecosystems are already in decline. Without swift action, we could lose the very ecosystems that help mitigate climate change. The time for complacency is over. The window of opportunity is shrinking, and we need to make bold moves. So, where do we go from here? We can start by dramatically reducing our carbon emissions, transitioning to renewable energy sources, rethinking our agricultural practices, and promoting sustainable industries are key steps. But we also need to focus on preserving and restoring our oceans. Because in the end, the ocean is the largest carbon sink we have. If we lose that, we lose the fight against climate change. But here's where the twist deepens. What if our current solutions aren't enough? Can we really rely on the ocean alone to fight back against climate change? Some experts argue that the ocean's role in the carbon cycle is overestimated. They believe that it's dangerous to put all our hope in the ocean. What if we're neglecting other solutions that could have a bigger impact? Perhaps it's time to rethink the entire way we approach climate change. Could technological innovations, like carbon capture and storage, CCS, hold the key to mitigating the crisis? While the ocean remains a powerful tool in our fight, it might not be the silver bullet. And this realization forces us to broaden our approach. We must invest in a diverse range of solutions, some of which might even involve the ocean itself. In fact, researchers are exploring the potential of using algae and other marine plants to